So now we're factoring by grouping with additive inverses, so that adds an extra step. Let's go ahead and see how these work. It's going to work the same way as number 3 and number 4. We're going to factor by grouping, so it's going to be c minus 2cd in parentheses plus 8d in parentheses minus 4 parentheses. So we want to look and see what can we factor out of the first polynomial. So we can see we have a c in both terms. So let's factor that out. We get c times 1 minus 2d, like that. Right. What can we factor out in the second polynomial? We can factor out a 4, because 4 is the greatest common factor between 8 and negative 4. Right. So we'll factor out a 4. So we'll say plus 4 parentheses 2d minus 1 parentheses. Right. So now we want to be able to factor these out and say c plus 4 times the polynomials inside the parentheses. But we cannot, because the polynomials in the parentheses are not the same. Right? So we're going to use additive inverse. And so how can we do that? Well, we're going to factor out a negative 1 out of this second polynomial. Okay, let me show you how that works. C times 1 minus 2d parentheses plus 4, and we're factoring out a negative 1 out of these two polynomials, right? And you can always factor out a negative 1. And if I factor out a negative 1 from 2d, what I'm left with is negative 2d. And if I factor out a negative 1 from negative 1, I am left with positive 1, like so. Okay. And so now all I need to do is rewrite this expression, and I'll have the same polynomials in the parentheses. Let me show you. 1 minus 2d parentheses minus 4 parentheses. And I'm going to rearrange these. I'm going to put 1 first, and I'm going to put the negative 2d after the 1, like so. And voila. Right? Now I have the same polynomial in the parentheses. And how did I do it? I factored out a negative 1, flipping the sign of each number in the polynomial in the second parentheses. Okay. So now they're the same. And so I could do c minus 4 times 1 minus 2d, like so. And I'm done. Right. So let me go ahead and put a box around that. And let's try it again over here. So we're going to start by grouping. And so we'll do 3p minus 2p squared. I'll put a box parentheses around that. And I'll do a plus a negative 18p plus 27 parentheses. So what are we going to factor out of the first polynomial? Well, 3 and 2 don't have a greatest common factor, right? But p and p squared have a p as a common factor. So I'm going to pull out that p. So in the parentheses, if I pull out the p from the first term, I'm left with the 3. And if I pull a p from the second term, I'm left with negative 2p, like that. And so on the right side, what can I factor out? Well, the greatest common factor between 18 and 27 is 9, right? So I'm going to factor that out, plus 9. So inside here, if I factor out that 9, it's going to be negative 2p. And if I factor out a 9 from 27, it is going to be positive 3. All right. So what we need, though, is we need these two polynomials in the parentheses to be the same. All right. And so how can they be the same? Well, we just need to rearrange these on the side. Right, these here. We don't need to pull out a negative 1 to flip the sign of everybody. We just need to rearrange them because they're the correct sign, right? Negative 2p and positive 3. So on this one, I'm just going to move them around. So rearrange them. So 3 times p minus 2p plus 9 times 3 minus 2p. Right? I just put them in a different order. And now we have the same polynomial in the parentheses. And so now we can factor. It's going to be p plus 9 as my first polynomial times 3 minus 2p as my second polynomial. And I have factor. So that is my answer. And I'm going to put a box around it, like so.